So we need to be able to convert from polar to Cartesian and Cartesian back to polar. Often you'll hear rectangular instead of Cartesian, but it's the same thing. So we're going to talk about this point here. We know that we can call it xy. And you might remember from earlier that we could also call it r cosine theta, r sine theta. Because if we call this angle here theta, and we know the length is r, we can use our Pythagorean theorem and SOHCAHTOA and figure out that the height of it must be the radius times the sine of theta, because sine is the opposite over hypotenuse. And similarly, if we want to find the the distance out of it, we can use the same thing but with cosine. So that should have been from geometry. So these two things are exactly the same, but we need to be able to put them in the points into polar coordinates, which we know is going to be r theta. So now if we are labeling this with polar, we can call it r theta. If we're labeling it with Cartesian or rectangular, it's xy. It just occurred to me, and I don't know why it's taken years and years for this to occur to me, but you need to stipulate which you're in. There's no like different kind of parenthesis that we use to say that we're in one or the other. Although often if you see like pi's here and integers here, they tend to be in polar, but you should be looking for other context clues, I think. Anyway, so we now have some direct conversions we can make from one to the other. We know now that r cosine theta is the same as x. So r cosine theta equals x. We also know that r sine theta equals y. And we know that we also know that this squared plus this squared equals this squared because of the Pythagorean theorem. So we know that x squared plus y squared equals r squared. So those are our big formulas that we need to know and to be able to use in order to convert from one type of coordinate system to another. So we'll take a moment and we'll do that. If I have, so I'm going to leave those equations down there. These are like the three big equations that I need to convert. So if I want to convert the point, let's say, so we have the Cartesian or the rectangular, and it is the point -2, 5. Well, now I have to figure out, well, what is r and what is theta? So we know that r cosine of theta equals -2. We also know that r sine of theta equals 5. We also know, I picked some bad numbers. Your numbers are going to be easier than this. We also know that r squared equals -2 squared. Notice this is going to become positive, plus 5 squared, which is this 29. So r is the square root of 29. Guess that's kind of an ugly number, but it's the square root of 29. Great. So we've got r. Now we need to find either the cosine or the sine so that we can do the inverse stuff. I much prefer to take inverses of cosine because I know the domain, or the range I should say, is from 0 to pi. So I'm going to say that I'm going to basically reuse this equation here. I could use this one if I wanted. Just have to be more careful. I'm going to use this equation. So I'm going to say the square root of 29 is, well, not is, times the cosine of theta is -2. If I divide both sides by square root of 29, so I get cosine of theta equals -2 over root 29. And then I can take the inverse cosine, which is what you guys already know how to do. So we just write inverse cosine of -2 over root 29. And I'm only looking for one of the answers. I don't need all the answers here. I'm just looking for one point that does this. So this is my angle. So this point, -2, 5, in polar is r, which is the square root of 29. And it is theta, which is this ugly thing here. It's the inverse cosine of -2 over root 29. -2 over root 29. And I don't even need to know exactly where that is. Like, that's just the point it's at. So I'm done. That's it. Maybe I could rationalize that denominator if I wanted to, but that's it. So so I can convert from rectangular to polar, and I can also then convert back from polar to rectangular. And I will do that right down here. So if I have, let's see if I pick something a little bit better. If I'm starting with polar, let's say it's got a radius of 3 and a radian measure of pi over 6. We want to convert it back. Well, I know that this is going to be the, or let's do it this way. X is going to be 3 times the cosine of pi over 6. I actually know the cosine of pi over 6. It's root 3 over 2. So 3 root 3 over 2 is my x value. And then my y value, I'm going to just do the same thing. It's going to be 3 sine pi over 6. And again, I happen to know this one. So it's going to be 3 over 2 because sine of pi over 6 is 1/2. So this is my polar, and I converted it back. We need these 3 formulas.